that is A is a vector, A is a matrix of this, and a vector, eigenvector is given. So it is asked the vector this is an eigenvector of this for what eigenvalue. So every matrix will have a eigenvalues, and every corresponding eigenvalue there will be a eigenvector. So what is the formula actually? A into x is equal to lambda into x, something of this format, where x is the eigenvector. This is the eigenvector. If you take this side, then it is a minus ax minus lambda x, that is equal to O matrix, null matrix. If you take that x, then it is a, actually this comes something like this, and from here you can remember, if you take this determinant equal to 0, that will give my lambda, which were the eigenvalues. So for vector, if a eigenvector is something of this formation, the entire matrix transformation along with that vector should be equal to the eigenvalue into eigenvector. So for that, because my x is given, this is x, this is the eigenvector given, you need to find lambda. So you multiply a into x, see what is happening. So then you can check lambda with your options. There are options given, a, b, c, d. You can check with the options. So if you multiply these two, a into x, so ax will be equal to, this is minus 2 plus 2 plus, so it is minus 2 plus 4 plus 3. So 4 plus 3, 7, 7 minus 2, it will be 5. So again, next one, 2 plus 2 plus 6, that is 10. And then the last one, minus 1 minus 4, that is minus 5. So again lambda into x. So what should be x is given. So x is 1, 2, minus 1. So you can see what should be lambda. From here also you can see. If you take 5 common, then it is this. So if you multiply it by 5, then 5 into 1, 5, 5 into 2, 10, 5 into 1 minus. So lambda is equal to 5. So the corresponding eigenvalue for the corresponding eigenvalue is lambda equal to 5, for which this is the vector. Now you can understand. So every lambda, for every lambda there will be one x, which will be equal to a into x should be equal. So this is the main formula for eigenvalue or eigenvector, from where actually everything came. So I'll go to then question number 9. So in 9, what is asked? The sum of the eigenvalues of this matrix. One matrix is given, the sum of the eigenvalues of it. This is a standard formula, the properties of eigenvalue. You remember all the properties. Here I am writing only 2. There are lots of other properties. The sum of eigenvalues, sum is equal to trace of A. What is trace? Trace is nothing but sum of the diagonal elements. So if you add the diagonal elements 2, 1, 3, 4, then it is 3, 3, 6 plus 4, 10. So this is the sum. The product, you also remember product is nothing but determinant of that matrix, that is delta. So if you take determinant, that will give you the product of eigenvalues, product of all lambda, that is nothing but determinant. So there are all other formulas, so you check the characteristics of all the eigenvalues. So this is always important questions for any competitive exam where matrix is in the syllabus. So your properties of eigenvalues, so you remember this one. Next I am going to question number 10. So what is given in 10? 10 is a set of linear equations represented by the matrix equation Ax equal to B. The necessary condition to the existence of the solutions of the system is the options are must be invertible, linearly dependent, column, linearly independent. So for this I will go for a little detailed explanation. What is dependent, what is independent? Let's understand this one. And what is this relation with the rank? Suppose you have a there is a equation 2 cross 2 equation, suppose means x plus y equal to 3 and then 2x plus 3y equal to 4. So this is an equation in matrix format. What we write 1 1 2 3 and then x y 3 4. So this is your matrix. If you multiply these into this, then it will come 1 into x plus 1 into x plus y, then 3. Similarly 2x plus 3y is equal to 4. So now you think of equation. Suppose this is the way to represent the equations in matrix. Suppose x plus y equal to 3. Now what I have done, I have given a new equation which is nothing but multiplication of this one. So 2x plus 2y equal to 3, just multiplying with t. So what is this? So these are known as dependent. You can see these equations is dependent on this, just multiplying on 2. This doesn't make any sense. If you make it in, so someone gives you these two equations, can you solve it uniquely? No, you will say that there is only one equation. How you will solve it? You multiply 2 minus Remember all old formulas class 10? You cannot solve it because ultimately effectively there are effective equations is only one effective equation. This is nothing but this is depending on this. So in matrix if you write it is 2 2. This is A, and if you suppose I am writing B along with this 3 3 6. So if you find the rank, what will be rank? For rank, if you will make it 1 and you will make it 0, so it will be R2 minus 2 into R1. If you do it, so ultimately it will become 1 1 0 0. Side by side, if I am doing this one also, then it is again 3 0, which is known as augmented matrix. Means if you are doing A, B side by side, both. So now you will see what is the rank of this one. You see the rank. Rank is 2. So what is showing is that rank is 2 means, rank is 1. So what it is showing that effective equation has been reduced. Number of effective equation is only 1. That's what the meaning. Physical meaning was also there. Number of, so from matrix also, now you get the idea what is the meaning of rank. So the number of effective equations reduces. So only one equation. So one equation, two unknown. Number of solutions will be infinite solution. Infinite solution. Similarly, you can think of for 2 cross 3, so 3 into 3 also. I will not go for 3. I will explain it in 2 2. The 3 3 will automatically you can understand. So let us stick to up to 2 variables only. So it will give you infinite solutions. Now you see, suppose what is the rank of A here from here? What is, this is A. This portion is A. And if you take the total, then it is AB, which is known as augmented matrix. Now if you write the rank of A, this is 1. What is the rank of AB? That is also 1. So both are 1. Okay. Now if both are 1, then it is infinite solution because it is less than even number of variable, that is 2. So if if the condition is that both the rank are not equal. Are not equal means what will be the situation? It will be 1 1 0 0. And if you take B, it is 3, but it is not 0 here. The 0 is not in here. So 3. Suppose any other or 2, non-zero. So the rank of A, if you see only this one, the rank is 1. Rank of A is 1. But the rank of AB, that is 2. So both are not equal. Both are not equal. So if you see the equation, what is the effect in the equation? The equation is something like that. X plus y equal to the first equation holds. That is okay. And the second equation is 0 into x plus 0 into y is equal to 2. Which doesn't make any sense. 0 plus 0 cannot be equal to 2. That means no solution is possible here. So for solution possible, what is the condition? Rank of A should be equal to rank of AB. That should be, this is the first condition. If this exists, then solution exists. Then we say it is consistent. Consistent. And now solutions, there are 2 conditions. There may be unique solution. Unique solution means you will find a proper value of x and y, and there is infinite solution. So when it will be, when the rank is less than number of unknowns. Our condition, this is that condition, our x plus y equal to 3, you don't have other equation, which is, they have given one equation, but it is depending on this, so it doesn't make any sense. So ultimately effectively one equation. So if your rank is reduced to number of unknown, rank was 1, unknown was 2. So in this case the solution was infinite solution, and the unique solution is the rank should be equal to number of unknown. If both are equal, then you will have both the equation preserved. So that means this condition. You will have both the equations with you. If you take rank of this one, you will find the rank of this one is equal to 2. So in this case, this will be the solution existence. And what is the condition solution not exist? This is the condition. Rank of A should not be equal to rank of AB. If both are not equal, then no solution. Or inconsistent we can write. Now you are getting it. So what is the question here? That the necessary condition existing of solution, only existing, no unique, no infinite. They are not asking you specifically it should be infinite or in unique. So for that, what I know, I need both the rank should be equal. So you see, one thing, first option you can think A must be invertible. Okay, A is invertible. We know this one, Ax equal to B, x equal to A inverse into B. Okay, if this is invertible, then what happens? Then you get unique solution only. Unique solution only. But the question is not about unique solution. Question is about only solution exists. So you don't only, if you think only for this one, it will not work. So that's why option A is not correct. So if you go for second option, B must be linearly dependent of columns of A. That means if you have A and you have B with you, This is your A. This is so B is a column matrix. So the column of B is depending on this column. This depending means what is depending? I have already depending is some multiplication or some addition. So two equation added and given a third equation, which is not a new equation, which is depending on the first two equation. In case of 3, in case of 2, I have shown you multiplying by 2, creating one equation, which is effectively not an equation. So this column 1 2, this column 1 2, this column 3 6. So you can see. So what is? So you can see there is a dependent. So B is depending on A. If B is depending on A, that means it is not a new one. If you calculate the rank, the B will automatically, rank of AB will be automatically rank of B, A. Sorry, rank of AB should be will also be rank of A. Why? Because B is not unique. It is depending on A. Whatever the rank of A, you will find if you take AB also, that will be also same. So that's why it should be dependent columns. If it is depending, then it is nothing but B is created from the taking the columns of A only. So if you do the transformation, the effective equations will automatically go down. So the rank of both the cases will be equal. So B will not create any difference in the rank creation. What will be the rank of A? That will be same for AB. Inclusion of B will not create any effect if B is depending on A. You can think of this condition 1 2 1 2 and 3 6. Here B, that is 3 6, is depending on column. Suppose this one 1 2 multiplied by this one. If you multiply this one by 3 is 3 and then 6. So if you take the rank, both the rank, if you see the rank of both are equal, both are 1. So this is the condition. That's why option B is the correct option for this one. Next you go for question number 12. Question number 12 is the determinant of the matrix, this one. So if you see the matrix is all these elements are 0. So what is this matrix? This is a lower triangular matrix, So in case of upper triangular matrix or lower triangular matrix, the determinant is always product of the diagonals. So what are the product? 1 into 1 into 1 into 1. This diagonal element. So if you take product, it is always 1. So the answer is 1. Number 13. What is the 13? The matrix equation Px equal to Q, which is the following necessary condition exist for at least one solution for the unknown. At least one solution means there may be more than one solution. So you can have unique also, you can have infinite also. So both is possible. You have to think for both. That means again you are going back to this one, this condition. So both should be equal. So augmented matrix PQ, that is PQ, here it is AB, in the question PQ, have the same rank as P. So this from here also the answer is A. So this consistency, inconsistency, rank, unique solution, infinite solution, these are always important topic in matrix, whichever the competitive exam is. So if you are preparing for any competitive exam where the matrix is in syllabus, you do take care of this consistency, inconsistency. If you have any doubt, you please post it in the